Have you ever just felt utterly depleted? Staring at a massive to-do list and thinking, ugh, I have no energy to do anything.
Oh, absolutely. Or that feeling of being, well, powerless.
Exactly. We've all been there, right? Totally drained.
Mhm.
But what if we zoom out a bit from our personal energy levels, and think about energy itself?
Energy in the broader sense.
Yeah. It's literally everywhere. It powers our bodies, obviously, but also the, colossal machines that quite literally build and shape our modern world.
It really does underpin everything.
So today we're going on a deep dive into the very essence of energy and power resources.
Right.
We've gathered a stack of fascinating sources to help us truly unpack what these resources are, where they come from, and why they form the absolute backbone of the modern industrial economy.
And that's precisely our mission today. We're going to set the stage for this journey, explore the diverse types of energy,
The different kinds.
understand the critical trade-offs involved with each one, because there are always trade-offs,
Oh.
and figure out what all of this ultimately means for our future, globally, and, for you personally.
That's key.
Our goal is really to equip you with a comprehensive understanding, but without feeling overwhelmed, because it's a huge topic.
It can be daunting.
We want you to feel perhaps a bit like that glowworm from the poem we found in our sources.
Oh, I like that one.
How can you be unhappy when light shines out from your soul? Maybe understanding energy gives a bit of that inner light.
That's a wonderful way to put it. It really captures the human side of it all, doesn't it?
Mhm.
It's not just about megawatts and barrels. Energy truly lights up our world in, well, so many ways.
It does.
So let's get right to the core of it. We all sort of instinctively know what energy is. It drives everything.
Right, the capacity to do work.
Exactly. But when we talk about power resources, we're digging into the specific fuels, the systems that generate that essential force for our machines, our industries.
The sources of the energy?
Precisely. At its heart, energy is simply the capacity to do work, to make things move or change.
Like you said, doing work.
Think about a fan whirring to life with electricity.
Yep.
Or your car roaring on fuel. Electricity, fuel, those are the fundamental sources making that work happen.
That's a crucial distinction you're making. While our bodies, run on energy from food,
Right, biological.
the machines that power our lives, our industries, they rely on what we call power resources.
Okay.
And these aren't just any resources. They're specifically those harnessed to generate energy. They are, and this isn't an exaggeration, the backbone of the modern industrial economy.
The absolute backbone. Couldn't agree more.
I mean, just try to imagine running any machine or vehicle without them. It's impossible.
It's not completely impossible.
And while most modern machines run on electricity, the source of that electricity is, well, it's a dynamic landscape.
It's changing.
Historically, it's relied heavily on burning fossil fuels or massive hydroelectric dams or nuclear fission.
The big conventional sources.
But increasingly, we're seeing it generated from newer sources. Wind and solar are the big ones now.
You've highlighted a critical distinction there. So, okay, machines need these power resources. How do we start sorting them out? Categorizing these myriad power sources.
Good question. That leads us straight to the big divide.
Which is?
Renewable versus non-renewable sources of energy.
Okay, the primary split.
That's the fundamental one. You really need to grasp this to understand our energy future. So on one side, non-renewable sources.
Got it.
These took literally millions of years to form, so they're finite.
Finite, meaning they run out.
Exactly.
Yeah.
Once consumed, they're gone, at least on any human timescale.
Yeah.
Think fossil fuels, coal, petroleum, natural gas. And also, nuclear energy fits here based on the fuel source.
Right, uranium, thorium.
They've been in use for a long time, so we often call them conventional. But, and this is a big but, they often come with significant environmental costs. Pollution, mostly.
A lot of pollution.
Oh,
Okay,
yeah.
so that's non-renewable. What's the other side?
The other side is renewable sources. These are continuously replenished by natural processes. Sun, wind, water, cycling.
Things that keep happening.
Exactly, so they don't get exhausted after a single use.
Yeah.
Their availability is, for all practical purposes, unlimited. They're inexhaustible.
Inexhaustible, big difference.
Huge. Examples include solar, wind, and hydroelectricity.
Hydro fits here too. Interesting.
Well, the water cycle is renewable, even if the dams are huge projects.
Yeah.
And a massive benefit here is that they generally don't cause environmental pollution during operation.
Much cleaner.
Much. And most of them are considered non-conventional sources, meaning they've been more recently developed or adopted on a large scale. sometimes called alternate sources of energy.
Okay, conventional versus non-conventional, renewable versus non-renewable. Got it. To give you a sense of where things stand right now, let's look at India's installed power capacity as of June 2024.
Okay, a snapshot.
Yeah, coal still dominates. It's at 48.7%, significant.
Nearly half. Wow.
Renewable energy, that's solar, wind, biopower combined, stands at 33.3%, a third.
Growing fast, but
Yeah.
still behind coal.
And hydroelectricity accounts for 10.5%. So what this shows us, really, is that while renewables are definitely growing,
And quickly, too.
conventional sources, especially coal, still make up a huge chunk of our energy supply. It highlights the scale of the transition that's needed,
Absolutely. That transition is the core challenge. So when we talk about conventional resources, we mean those that have been in widespread use for a long time.
The old guard, so to speak.
Pretty much. This category includes those traditional fuels like firewood and cow dung.
Right, the very earliest ones.
The big fossil fuels, of course, and also hydroelectricity, despite its renewable nature, because large dams have been around for a while.
Okay, let's start with the earliest then. Firewood. It was, one of the very first fuels humans used, wasn't it? For heating, cooking.
Absolutely fundamental for early civilization.
But our sources really highlight the downsides now. It generates a lot of smoke, causes pollution.
Indoor air pollution especially.
Which is hazardous to health, definitely.
Yeah.
And it harms the ecosystem, deforestation, loss of habitat.
Big impacts.
In fact, while its use is globally discouraged now, it's still common in parts of rural India.
And the data on the health costs is frankly shocking. Kirk R. Smith, a professor at UC Berkeley, he pointed out there are over 3,000 chemicals identified in wood smoke.
3,000. Wow.
Yeah, remarkably similar, he says, to tobacco smoke.
That puts it in perspective.
When further research, this time by Sagnik Day from IIT Delhi, attributed about 13%, that's 270,000 deaths in India, to air pollution from these dirty household fuels. Wood, dung, coal, kerosene.
It's a staggering number, a silent killer, as you said.
Truly. To tackle this, the Indian government launched the Pradhan Mantri Ujjwala Yojana PMUY.
The LPG scheme.
Exactly. Providing free LPG connections to poorer households. LPG, that's liquid petroleum gas, mainly propane and butane.
Cleaner burning.
Much cleaner. And it's interesting, LPG itself is naturally odorless and non-toxic, but they add a tiny amount of ethyl mercaptan.
That smelly stuff.
Yeah, the rotten egg smell. It's added specifically so you can detect leaks. A simple but crucial safety measure. Really shows how these fuels are engineered for practical use.
That makes sense. And alongside firewood, there's cow dung, another historical fuel.
For millennia.
But again, burning it directly is highly polluting. Increasingly, people see its value more in farm manure or for biogas production.
Right. Biogas is a much cleaner way to get energy from it. More efficient, too.
Okay, so from those traditional fuels, let's move to the giants. The fossil fuels. Coal, petroleum, natural gas, the ones that really powered the Industrial Revolution and beyond.
The powerhouses, exactly. They were all formed, as you know, over millions of years. Dead plants, animals, immense heat pressure.
Ancient biology transformed.
That's why coal gets called buried sunshine. It's ancient solar energy captured by plants millions of years ago, stored underground.
Buried sunshine, I like that. And coal has been just immensely important since the Industrial Revolution, hasn't it?
Absolutely central.
Its abundance, its energy density, it led straight to coal-based power plants churning out thermal electricity, the foundation for so much.
It powered factories, trains.
Steam locomotives, brick kilns, forging, the iron and steel industry. It was everywhere.
Globally, the major producers are countries like China, the USA, Germany, Russia. Russia actually has some of the largest reserves.
And in India.
Famous coal mining regions like Raniganj, Haria, Dhanbad, Bokaro, historical hubs.
Right.
And what's interesting is that coal isn't uniform. It comes in different grades, 4 main varieties.
Oh, yeah.
From anthracite, which is the best quality, high energy, burns cleaner, down to lignite and then peat, the lowest quality.
So the type matters a lot.
Absolutely. It affects efficiency, pollution levels. Lower grades often mean more ash, more emissions for the same amount of energy. It's not just trivia. It's crucial for environmental impact.
Okay, good point. Then there's petroleum, oil.
The other giant.
The world has limited reserves. We know that. Kuwait and Saudi Arabia hold the largest known reserves.
The Middle East dominates, yeah.
Other big producers include Russia, the USA, Venezuela. Within India, we find it in places like Digboy in Assam, that's a very old one.
Historic field.
The big offshore Bombay High Field, and down in the river deltas of the Krishna and Godavari. Our sources list these, but the real point is their strategic importance, right? Energy security, the complex logistics.
Absolutely. It shapes geopolitics, trade, everything. And petroleum is incredibly versatile once refined.
It really is.
It gives us petrol, or gasoline for cars, diesel for trucks, buses, trains, and some power generation. Kerosene, still vital as a household fuel in many places.
We're cooking and lighting.
But it's also a chemical feedstock powerhouse. The bitumen for roads, plastics, lubricants, synthetic textiles, even insecticides and pharmaceuticals.
So much comes from it.
An incredible range of products. But the downsides are stark. It's fossil fuel, so it's finite, exhaustible, and burning it releases significant pollution.
Which brings us right to a major shift that's happening now, the move towards EVs.
Electric vehicles, yeah.
Yeah.
A huge trend. They run on battery-powered motors, so you get drastically reduced tailpipe emissions or none at all.
Cleaner air in cities, potentially.
And even further out, people are experimenting with hydrogen-powered vehicles. They emit only water and heat.
Still early days for hydrogen infrastructure, though.
True. But look at Norway. They're really leading the EV charge, aiming to stop sales of fossil-fueled cars by 2025.
Yeah.
Recently hit, 58.4% of new car sales being fully electric.
Astonishing rate of adoption. Really shows what policy can achieve.
And India also has ambitious plans, a major shift towards EVs planned by 2035.
It's a global shift.
Then the third fossil fuel, natural gas.
Right.
It's a key motive fuel, for vehicles, and also a crucial industrial fuel for heating, processes, making chemicals.
Mostly found with oil.
Often found alongside crude petroleum deposits. Yeah, but it can exist on its own, too.
Yeah.
The USA is the largest producer.
Okay.
Other big reserves are in Russia, the Netherlands. In India, you find it in Jaisalmer in Rajasthan, those Krishna Godavari deltas again, Tripura, and offshore near Bombay High.
And it's famously used as CNG, right? Compressed natural gas.
Yes, especially in automobiles, buses, taxis, cars.
And the key advantage there is
Lower emissions. Its emissions are significantly less than coal or petroleum. It burns cleaner, so it causes less air pollution. Still a fossil fuel, still emits CO2, but less of the other harmful stuff.
okay, so a bit cleaner, but still conventional and finite.
Exactly. So if we summarize the general disadvantages for all fossil fuels,
Yeah.
1, polluting, big one.
Definitely.
2, for coal especially, disposal of fly ash is a difficult environmental challenge. Huge volumes of waste.
Right. What do you do with it all?
And 3, exploration of new reserves is getting harder, more expensive, and often environmentally disruptive itself.
Makes sense. Okay, so that covers the big fossil fuels. What about the other major convention and source you mentioned, hydroelectricity?
Right, hydro. Our sources mention its ancient roots too, like in rural areas using water power for grinding wheat in something called a garrote.
A water mill, basically.
Yeah, water from a small river channeled to turn a grinding stone. Simple, ingenious.
And that basic idea eventually scaled up massively, right? To the modern hydroelectric projects we see today.
Massively. Huge dams, complex tunnels to channel water, sophisticated powerhouses with turbines and generators.
A scale is incredible.
It is. And the advantages of modern hydro are pretty significant. First, it's a renewable resource because it relies on the water cycle.
Water keeps flowing.
And second, during operation, it does not cause pollution. No smoke, no greenhouse gases directly from generation.
Okay, renewable, non-polluting, what's the catch?
The main drawback is the upfront investment and time. Constructing these massive projects is incredibly time-consuming and needs lots of capital.
Yeah.
We're talking decades and billions of dollars sometimes.
Huge undertaking.
Huge. Countries like Canada, Russia, China are leading producers. India also has significant hydro capacity.
Yeah.
P.L. Nehru famously called these big dam projects the temples of modern India,
High praise.
reflecting their importance for development at the time. You have major projects like Bakranangal on the Satluj River,
A classic example.
Hirakud on the Mahanadi in Odisha, Sardar Sarovar on the Narmada in Gujarat. Iconic projects.
But as our sources strongly remind us, there's always the other side of the coin.
It's crucial to look at that.
We absolutely have to consider multiple perspectives. The Narmada Bakshau Andolan, for instance, that was a major movement opposing the Sardar Sarovar Dam.
A very prominent environmental and social justice movement.
Largely started by villagers, right? People who were forced to leave their homes, their fields, to make way for the dam and its reservoir.
Exactly. Displacement is a huge social cost of large dams. But it's not just social impacts. These projects can cause, as the source says, a number of ecological problems as well.
Such as?
Things like altering river flows, which can impact downstream ecosystems, sedimentation buildup behind the dam, potential links to localized earthquakes in some cases, loss of forests and wildlife habitat due to the reservoir flooding land, soil erosion.
A whole cascade of environmental issues.
It can be quite significant.
Yeah.
And the source doesn't shy away from the ethical dilemma. It asks, point blank, is it fair to ask few people to sacrifice for the benefit of others?
Oh, that's a tough question.
It's a question without an easy answer. It really highlights the profound ethical and social dimensions embedded in our energy choices. It's never just about the technology or the economics.
It's about people, communities, the environment, deeply interconnected. Okay, so that covers the conventional sources. Let's pivot now.
Right, let's move to the non-conventional resources.
The newer players on the scene.
Generally, yeah. These are energy sources that came into widespread use much later. And with one big exception, they are all inexhaustible and renewable.
Yeah, and that exception is?
Nuclear power.
Okay. Let's start there then. Nuclear power. One of the newest and definitely one of the most potent sources of energy.
Extremely potent. It generates electricity using heat, but the heat comes from nuclear fission.
Splitting atoms.
Essentially, yeah. Splitting the nuclei of heavy atoms like uranium, sometimes thorium, inside a reactor. This releases an immense amount of energy as heat, which then drives turbines, like at a conventional power plant.
Okay, and the fuel sources are uranium and thorium.
Those are the primary radioactive heavy metals used. The USA currently has the most nuclear power stations operating globally.
Right.
Other important producers include countries like the UK, Japan, Canada, Russia, France too.
Then India.
India has fairly good domestic deposits of uranium, mainly in Rajasthan and Jharkhand, and significant thorium deposits, particularly in the beach sands of Kerala. We have key nuclear plants like Tarapur in Maharashtra, Rohbade in Rajasthan, Kudankulam in Tamil Nadu.
So we have the resources and the plants. What are the pros and cons?
The advantages are compelling. First, it produces a massive amount of energy from a very small amount of fuel, incredibly energy dense.
Gauge power output.
And second, during operation, it has very low greenhouse gas emission. No CO2 comes from the fission process itself. That's a major climate advantage.
Okay, energy density, low emissions. The disadvantages.
They are equally significant. First, it's incredibly expensive to set up the nuclear plant. Huge capital costs, long construction times, complex engineering.
Very high barrier to entry.
Very. And second, the big one, disposal of radioactive waste. The spent fuel remains hazardous for thousands, even hundreds of thousands of years. Finding safe, permanent storage is a persistent and frankly largely unsolved global problem.
The waste issue is huge. Okay, let's move to the renewables in the non-conventional category. Solar energy.
Yes, solar.
Our sources suggest this could be a major answer to most of the energy woes of India, especially since India is, blessed with abundant sunshine pretty much year-round.
Huge potential, geographically.
And it's incredibly versatile. You see it in basic things like solar cookers and solar water heaters.
Simple, direct use of heat.
But critically, it's used to produce electricity via solar cells, photovoltaic panels, powering everything from streetlights, park lights, homes, industries, even running tube wells for farmers in remote areas.
Bringing power where the grid might not reach easily.
Exactly. What are the core benefits?
Well, the big ones are obvious.
Yeah.
It's inexhaustible, the sun isn't running out anytime soon, and it's eco-friendly during operation. No emissions.
Free fuel, basically.
The fuel is free, yes. Though the initial setup, the panels and equipment, can be expensive. That cost has come down dramatically, though.
True. It's much cheaper now.
India has set really ambitious targets.
Yeah.
Aiming for 100 gigawatts of solar power as part of a larger 175 GW total renewable goal by 2022 initially, and continuing to expand.
How's India doing globally?
Pretty well. Back in 2018, India ranked second, right after China, in the Climate Scope report for clean energy investment and deployment. That's significant.
Wow, second place.
And the government has launched major initiatives to push solar, like the Kusum mission.
What's that?
It helps farmers install solar panels on infertile or fallow land so they can generate power, use some themselves, maybe sell the surplus, turns unproductive land into an asset.
Smart idea.
And the Srishti scheme focuses on rooftop solar panels for residential buildings. Plus, there are subsidies on solar appliances and even discounts on electricity bills sometimes to encourage people to adopt solar.
Lots of policy support then. Any downsides to solar apart from initial cost?
Well, it's a diffused source. meaning sunlight is spread out, so you need a relatively large area of panels to generate a significant amount of power compared to, say, a compact nuclear plant. That makes it less efficient in terms of land use.
Takes up space.
And obviously it depends on sunshine, doesn't work at night, less effective on cloudy days, so energy storage or grid balancing becomes important.
Okay. Next up, wind energy.
Wind power, another ancient concept, really.
Right. It's been used for centuries. Sailing ships, windmills for grinding grain or pumping water.
Exactly. But like solar, it's only more recently been harnessed for large-scale electricity generation using modern wind turbines.
Those huge white turbines you see.
Those are the ones. Countries like the Netherlands, Denmark, Spain, USA, UK, Germany are well known for their extensive wind farms, both onshore and increasingly offshore.
And India.
India is also utilizing wind power significantly, particularly in windy states like Rajasthan and along the coast of Gujarat and Tamil Nadu, where the wind resources are strong.
Advantages are similar to solar, I assume.
Pretty much. It's inexhaustible. Wind is a natural phenomenon and non-polluting during operation. No emissions.
Downsides.
It has its own set. First, like solar, it's unreliable because wind speed varies constantly. Sometimes it's calm, sometimes it's too strong. Grid integration needs management.
Fluctuates a lot.
Second, large wind farms can sometimes disturb radio and TV reception locally.
Oh, interesting. Didn't know that.
And sadly, the rotating blades can hit birds, especially migrating birds. That's a real ecological concern that needs careful site selection and mitigation.
Right, the impact on wildlife.
And finally, similar to solar and hydro, setting up large-scale wind farms is expensive due to the cost of turbines, infrastructure, land, and grid connection.
Okay. Are there other non-conventional sources mentioned?
Yes, briefly. Our sources touch upon biogas.
From organic waste.
Exactly. Produced from the anaerobic decomposition breakdown without oxygen of organic waste like cow dung, sewage, crop residues. It's eco-friendly, produces a burnable gas, methane for cooking or electricity, and the leftover sludge is a great fertilizer.
Closing the loop in a way?
Sorta, yeah. Then there's geothermal power.
Heat from the earth.
Harnessing heat from the Earth's interior, usually in areas with volcanic activity, hot springs, or where the crust is thinner, can be used directly for heating or to generate electricity.
Limited geographically, I guess.
More limited by geology, yes. And finally, tidal energy. Using the power of ocean tides, the rise and fall of sea levels, to turn turbines.
Huge potential power in tides.
Huge, but technologically challenging and site-specific.
Hmm.
So these others exist, but solar and wind are the dominant non-conventional renewables right now.
Got it. Okay, this brings us to a really crucial point, a serious concern. The conservation of energy resources.
Absolutely vital.
Our sources are quite stark here. They warn that the fossil fuels, which have, powered the world pretty much up till now, they're finite.
We established that.
And recent studies cited suggest that at current consumption rates, they might not last much longer, maybe only 30 to 40 years more for some key reserves.
That's a sobering time frame within many of our lifetimes.
And this rapid consumption is being driven by, well, everything. Growing industries, more and more automobiles worldwide. The demand keeps rising.
And this depletion isn't happening in a vacuum. It's directly linked to severe environmental and health impacts.
How so?
Well, the pollution caused by burning these fuels is already, as the source puts it, playing havoc with our health, contributing to so many diseases, respiratory illnesses, cardiovascular problems. Some are fatal.
The air quality impact.
Exactly. And beyond direct health effects, the Earth's temperatures are soaring with every passing day. Why? Because of the massive volume of greenhouse gases, primarily CO2 released when we burn fossil fuels.
Climate change.
It's a dual crisis, really. Resource scarcity looming on one hand and environmental devastation happening right now on the other.
So what can we actually do? What do the sources suggest for conservation?
They outline some essential steps. Pretty logical, actually. First, and most obviously, reduce the use of fossil fuels.
Use less of the stuff that's running out and causing problems. Makes sense.
Second, actively encourage and popularize the use of alternative, non-conventional, and renewable sources of energy. We need to accelerate that transition we talked about.
Push renewables harder.
Third, a simple but potentially high-impact behavioral change. Encourage the use of public transport. Fewer individual cars means less fuel burned overall.
Reduces congestion, too.
Absolutely. Fourth, just use electricity judiciously. Be mindful. Switch off lights, fans, air conditioners when they're not actually needed.
Basic energy-saving habits.
It sounds basic, but aggregated across millions of people, it makes a difference. Japan even has, or had, a law recommending ACs be run at 25-27 degrees Celsius to save energy.
Setting thermostats higher?
And finally, a technological fix.
Yeah.
The smart use of LED and CFL lights, moving away from old incandescent bulbs.
Right, you mentioned those earlier. LEDs are better than CFLs.
Yes, let's compare them quickly.
Yeah.
CFL's compact fluorescent lamps were a big step up. They use maybe 75% less energy than old incandescent bulbs and last much longer.
Good improvement.
But they do contain a small amount of mercury, which is toxic and makes disposal tricky.
Ah, the mercury issue.
LEDs, light-emitting diodes, are even more energy efficient than CFLs. They last incredibly long, maybe 25,000 to 50,000 hours.
That's years of use.
And crucially, they don't contain mercury or other harmful metals. Plus, they give instant light, unlike CFLs, which sometimes need a moment to warm up. So LEDs are really the way to go now for lighting efficiency and safety.
Clear winner there.
And it's really inspiring, actually, to look at India's progress in this whole area. India is emerging as one of the largest producers and deployers of renewable energy sources.
We're making big strides.
Significant strides. That solar capacity figure, for example, increasing tenfold between 2014 and 2018, that's rapid growth.
10 times is huge.
And we have some fantastic concrete examples that show this commitment in action. Like Kochi in Kerala. It is the world's first and, at the time of the source, only 100% solar-powered airport.
An entire airport running on solar? Wow.
The whole thing. And Guwahati in Assam has India's first wholly 100% solar-powered railway station.
Airport, railway station. These are big facilities.
So is it scalable. And another cool example from Kerala, the first and largest floating solar power plant in India was built on the Banasura Sagar Reservoir. Panels floating on water.
Saves land use, too.
Exactly. These aren't just pilot projects. They're real-world testaments to what's achievable with renewables.
Yeah.
It's genuinely hopeful.
It really is. What a journey we've taken then. Through this really diverse, sometimes complex and challenging, but always fascinating world of energy and power resources.
It covers so much ground.
From the ancient crackle of firewood right up to the, cutting-edge hum of solar panels and wind turbines. Understanding these resources, it isn't just about memorizing facts, is it?
Not all.
It feels like it's about shaping our collective future, understanding the incredibly complex web of what powers our modern lives.
Absolutely. And as we wrap up this deep dive, maybe here's a final provocative thought for you, the listener, to ponder.
Okay, leave us with something to think about.
Given everything we've discussed, the finite nature of some resources, the environmental impact of others, the social costs, what does it truly mean to be energy efficient?
Beyond just switching off a light.
Exactly. Beyond the simple habits in your own life, sure, but also in the broader global context. How do we balance individual choices with the need for huge systemic shifts in how we produce and consume energy?
The personal versus the systemic.
Yeah. Perhaps understanding this complex world, like that glowworm maybe, can make some light shine out. Empower you to think critically and make more informed choices about energy, both big and small.
That's a powerful question to leave us all with. Thank you for joining us on this deep dive into the world of energy.
Pleasure to discuss it.
We really hope you feel a little more enlightened, maybe a bit more empowered to think about this absolutely vital topic.